Hello, everyone. Welcome to Psych 301, Chapter 2. My name is Jill Yamashita, and I will be going over Chapter 2, Central Tendency. So, the learning outcomes for Chapter 2 are to 1. Define what descriptive statistics are. 2. Describe the mean, median, and mode. 3. Calculate the mean, median, and mode. And 4, to identify when to use a mean versus the median. So let's begin. Descriptive statistics are summarizing and reducing large numbers of sets of number. Summarizing and reducing large number of sets to meaningful displays and representative indices. Indices like the mean and the median. There are different degrees of simplification that one can use for descriptive statistics. For example, central tendency, which is what we're going to deal with in Chapter 2, and variability, which is what we're going to deal with in Chapter 3. Now, the thing to be aware of when it comes to descriptive statistics is that the numbers that come from central tendency and variability give us something very, very specific. So, for example, when you solve for the mean, everyone knows that that means you're solving for the average. So you have a distinct definition of what that is for the reader. So the first thing we're going to talk about are the different indices for central tendency, the mean, median, and mode, and how to calculate them. And then the last thing we're going to talk about is when to use the mean versus the median. So again, central tendencies is basically a number that indicates or provides an index that is typical for an entire set of scores or data. Now here's the thing about the word typical. You want it to describe the majority of the scores that are in your data set. So we're going to get more into that when we go into the mean versus the median. So let's start with the first central tendency, the mean. The mean also indicated by a large M, but in this class we're going to use Y bar. The mean is the arithmetic average that is influenced by both large and small scores within your data set. You can only use interval and ratio measurement scales when doing a mean, because if you use the ordinal or nominal measurement scales, the numbers won't actually mean anything. So the mean won't tell you anything. Here is the equation. So we have Y bar. Now Y bar is, of course, the indication for the mean, equals to the sum of. Now the funny looking E is actually the summation sign, or the uppercase sigma, which indicates addition. So when you have sigma large Y sub I, that means the sum of all of my scores added together. So I'm going to take all my scores, I'm going to add them together, and then I'm going to divide by small n. Small n is the number of scores in my data set. Okay, so again, the uppercase sigma is an operator that indicates addition or the sum of something, and in this case the sum of scores. So yi is the score. So yi indicates the ith score. So if you have y1, that means it's the first score. Y2 means the second score, etc., etc. Divided by the total number of scores, which is small n. Okay, so here's an example. We have a data set with 10, 6, 12, 8, 6, 15, 16, and 6. And I want to solve for the mean. Well, if you look at the equation, the top part of the equation says the sum of yi. So I'm going to take the sum of all of my scores. So 10 plus 6 plus 12 plus 8 plus 6 plus 15 plus 16 plus 6. All of that divided by n. Well, in this case, we have 8 scores, so we're going to divide by 8. So if we take all the numbers in our data set and we add them together, we get a value of 79. And then we divide that by 8 and we get 9.88. So if you notice, I rounded to 2 decimal places. And so that's what I'm going to ask you to do as well for this class is to round to 2 decimal places. So in this example, the mean or the average is 9.88 for the data set. So that's the mean or the average. The second index for central tendency is the median. The median is the middlemost score in a data set. It is not influenced by really high or really low values. This, again, should only be used for interval or ratio scale that are used. Cannot be used for nominal or ordinal data sets. Once you have your data, you need to rearrange them in order of magnitude. Magnitude is the strength. So, for example, you can order it from lowest to highest number or from highest to lowest number. And the median score is the middle score or the middle value. So and one more thing. If you have an even number of data, so for example, if I had 10 pieces of data, that means I'm going to have 2 numbers in the middle. And in this case, when you have an even number of scores or pieces of data, you're going to need to take the average of those 2 middle numbers. If you have an odd number, well, then there's only going to be 1 number in the middle. Oh, and if you were curious how to find that middle number, let's say again you have 10. You divide that by 2 and you get 5. So you count from the first one, you count down 5, you go to the bottom, you count up 5, and then those are your 2 numbers that you're going to take the average of. If you have an odd number, for example 9, and you divide that by 2, you get 4.5. You raise that up to a 5 and you count from the top number, you count down 5, and you go from the bottom number, count up 5, and you'll find that it's exactly the same number. So using the same exact data set that we had for the mean, 10, 6, 12, 8, 6, 15, 16, and 6, we're going to solve for the median. So again, the first thing we're going to do is we're going to order it from lowest to the highest number. So I have done that. And again, we have in this case 8 different numbers. So we're going to count from the top down 4. So we have 6, 6, 6, 8. 8 is the 4th one. And then you go from the bottom number, 16, and you count up 4. So 16, 15, 12, 10. 10 is the 4th number. So you have 2 middle numbers, an 8 and a 10. And like I was saying before, what we need to do is we need to take the average of these 2 numbers to get the median. So if we have 8 and 10, that gives us 18. Divide that by 2 because there's 2 numbers. 18 divided by 2 gives us 9. So 9 is the median for this data set. Now another example of a median, I took out one of the numbers, so now instead of having 8, we have only 7 numbers. Again, we're going to order it from lowest to highest. But this time we have 7. So 7 divided by 2 is 3.5. So we go up to 4. So we count down 4, starting with 6. Starting with the first number, 6. So we go 6, 6, 8, 10. And we stop, and that's the 4th one. Then we start from the bottom. We go up 4, 16, 15, 12, 10. And look at that, 10 is the middlemost number. Okay, so that would be our median in this example. Okay, so that's if you have an odd number of data. The last central tendency index is the mode. Mode is the most frequently occurring score in a data set. Now, it conveys a popularity of information, what number or what data or what score was the most common in the data set. So oftentimes this is not used in experiments, but for teachers, we use mode a lot to get an idea about how well our students are doing, and we look at the mode to see what is the most frequently occurring score, or in this case, grade, to determine if there's what we call a bimodal distribution. In other words, more than one mode. And in that case, we need, as a teacher, to be able to help those who are in the lower end of the mode or having a lower number. Okay, so here we have the same original data set, and if you notice, 6 is the most occurring number out of this data set. There are 3 6s, so 6 would be the mode for this example. So those are our 3 indices, the mean, median, and mode. Now, when to use the mean versus the median? That's a great question. I'm sure you're all dying to know what is the answer to this. Well, the mean is a great representative for a group when the numbers don't have what's called an outlier, a number that is either too large or too small, which would then skew the data. So scores on a memory test is actually a very good representation of when to use the mean, because typically people are between 5 and 9 on a memory test. Now, that's great if you don't have any outliers, but what happens if you do? Well, then we discuss when should we use the median. When the mean has outliers, really high or really low numbers that influence the mean or skew the mean either to be higher or lower than what it actually represents, then one needs to think about using the median. An example of this would be real estate. Realtors oftentimes will not report the mean for a home cost. It oftentimes will be the median that is reported, and that's for a very good reason. Think about Monterey County. We have a lot of houses that are in multi-million-dollar homes. Is this the case for most of the county? No. So these would be very, very large outliers. They would increase the average home price. And so people might not consider living in Monterey County because they think the houses are a lot more expensive than they actually are. So one would use the median or the middlemost point to get an idea about how much it's going to cost to live in Monterey County. So when do you use the mean? When the mean is a good representation for your data. When you use the median, when you have outliers that in some way skew the mean either to the large or to the small side of the spectrum. All right, so that is the end of chapter 2.